Ever since I built my main video editing rig here, this is X79, a lot of you guys have been asking for an overclocking tutorial for it, so who am I to deny a very worthy request from you guys? Today we're going to be getting straight into it, and we're overclocking the 8-core Xeon, the 1680 V2. Welcome back to Tech Yesterday, and right here on the desktop I have 3 programs that I cherish for overclocking. And I'm going to start recommending this one right here, Dota 2, because it's free to play. You can download it and you can just even boot up the single player and it will find unstable overclocks so quickly. i7-3930K, we're going to use this for stress testing the CPU and seeing that our overclocks are actually locking in and they're stable, as well as looking at our memory speeds. And then Cinebench, we can actually just ascertain that our overclocks are indeed working at the correct speeds by looking at the score that this gives out and seeing that it's indicative of what other people would be getting. With that aside, let's restart our machine and boot into the BIOS by pressing F2 or the delete key. We are in the magical land of the BIOS, and this is the Asus BIOS, which is of course going to look different to the ASRock, MSI, and Gigabyte versions. And if you're on a huanan, then I feel sorry for you, but this is a fast boot as well. So the boot settings here, I'm going to quickly point this out before we move on, because I'm on NVMe, which is kind of hard with X79 because it was never really natively supported from it. You've just got to use an add-in card on the PCIe slots and then mod the BIOS to support it. But what we've got here is fast boot, so we need to disable that. And we can see here with boot option 1, now that we've done the natural order of installing from the SSD, it recognizes it as Windows Boot Manager. So you can also post delay time, drop that down to 1 second or 0 seconds. I usually like to have it at 1 second. I think the default is 3 seconds. That'll just help your PC boot up a little bit faster. So now that we've got that out of the way, we can go over to the, by hitting the left and right keys, over to Extreme Tuner. Now, of course, it may be called something different in the other BIOSes, but what we're looking up for here is the CPU core ratio. And we just want to hit enter, and then we want to go sync all cores, because Ivy Bridge, essentially this is the architecture with X79. You've got Ivy Bridge and Sandy Bridge, the 3930Ks and also the 4960Xs and all that stuff. Keep in mind the Xeon, the 1680 V2 that I'm using here today, is pretty much the cream of the crop. You're not going to get a better chip on X79 than these Xeons. Not only are they the best bin, but they're also 8 cores, 16 threads, which the consumer i7 desktop lineup had no 8-core equivalent. So it's a very unique CPU. And in fact, it's such a good CPU to the point where I don't think you'll be able to replicate the voltages at the levels I'm going for. So I'm going to be overvolting my CPU now and today, just for the sake of helping guys who don't have the Xeons. But we want to sync all cores here and then go to the 1-core ratio, which will now be linked to all the 8 cores. And I'm going to drop this, say, we're going to start off with 4.4 gigahertz, because that should be obtainable for anyone who's got a water cooler, a decent X79 motherboard, and a 3930K, for example. Now, other things to get out of the way as well. I do have pretty much the best of the best X79 board. I didn't waste any time when I hustled the deals. I made sure that I not only had the best Xeon, but I picked it up for a really good price, but also picked up a really good Xeon board, X79 board for a really good price as well. So that board, coupled with the fact that I'm using a really good power supply, enables me to have low ripple and achieve higher overclocks for lower voltages as well. So there's all these other factors that are pretty much leaning my voltage levels to probably not be that indicative of what the average person could obtain. So anyway, 4.4 gigahertz, locked it in. Now we're going to worry about DRAM frequency later. Always overclock your CPU first and try to obtain the highest overclock that you can for that CPU's level. So we're going to go down to Digi Power Control, CPU line load calibration. I like to have this somewhere on either medium or high, but since we are, again, using a really good power supply, we've got a really good VRM, high would be the most I'd take it to. If you've got, maybe you might want to go ultra high, but high is going to work well for me, the third setting from the top. CPU current capability. Now this is very important because it's just the capabilities of your CPU. You can set this to the maximum because it's just going to allow more power if it's needed to go through. CPU voltage frequency, we don't have to touch that. VRM over temperature protection, we can leave that on auto. It just protects your VRM from getting too hot. It's mainly for LN2 overclockers. But essentially what we're doing now is we're setting settings on high, VCSA as well, And we're just setting these current capabilities so that there's no bottlenecks when we're overclocking. Essentially, there's nothing that can limit our overclocks, because some of these current capabilities can indeed cause problems on your motherboard. And so we're setting those up. We're giving them more capabilities to be able to allow more voltage to go through, but at the same time we're still keeping the protections in place. CPU performance settings. We don't have to really do much here. You can leave turbo mode on. I find it's not a problem. And same with the enhanced speed step technology. You'll actually want them on, because when you're overclocking and you're not in use, you'd want it to downclock. So now extreme overvolt as well. You can enable this if you want to. It's not a big thing. I do leave it on enabled because essentially it just allows you to have more voltage to go to the CPU. But of course, there's a voltage protection. You shouldn't really need it for 4.4 gigahertz. If you just want to keep things super safe, then you can just leave that on disabled. I'm sure for 4.4 it should be fine. But here we've got CPU V-core voltages. So I like to set this to manual mode, and then I like to go to I mean, on my CPU I can go 4.4 at 1.24. That's very easy. I think most people will have to go to 1.3 at 4.4 gigahertz. Maybe they might need a little bit less, a little bit more, but again, depends on those circumstances. But very important setting. Same with this here. This is the VTT CPU voltage. That's what essentially allows the CPU the thickness of the band going to the voltage that supplies essentially the cache, as well as the cache ratio and stuff like that. So you want to leave this about 1.15. You may wish to go 1.18. It's not a big deal. Of course, maybe leave this a little bit higher again, because my CPU's a nice CPU. The second VTT, I have no idea what this does. I've never seen this before on X79 besides this motherboard. Very interesting setting. Yeah, I mean, Asus just offer these settings that I see and I'm like scratching my head. But here's another one here, the VCC SA voltage. This is the system agent, and essentially it's responsible for managing the PCI Express controller and also the input-output. So we can set this to the default by standard is, I think it's 1, but you can set it to 1.05 just to give it a little bit extra juice, and that'll just make sure that there's no problems there. Now, DRAM, of course, I had mine previously at 1.54, hence why there's the voltage is locked in there. CPU PLL as well. You want to raise this above the standard of 1.8, I believe that's the default. You want to put this up to 1.86, just to allow your CPU, again, to have the band of the power going to the CPU itself. So there's nothing bottlenecking that CPU when it requires the power needed to get going. Platform chipset hub, you will not have to change this at all. 1.1 is the standard. You can leave it at that. You might even want to downclock this to 1.05, since again, we've got good gear on this. But it's not really necessary, so we don't even have to worry about that. CPU spread spectrum disabled, PCI spread spectrum disabled. And so those are essentially, if you've got wireless interference, you don't need to bother with them. CPU tweakers paradise, PCIe clock skew and stuff like that. Don't really have to worry. These are just Asus's fancy showing off settings, mainly for LN2 overclockers and people going to break records. They're just these really intricate settings that does, in ways, set Asus aside from other motherboard manufacturers. So now that we've done that, we're essentially got the CPU locked in. We haven't bothered with the DRAM just yet, because we're going to see if we can boot at 1.3 into Windows. And after that, we should be good to go. So if you want, you can save this as a profile. There should be the option to save it wherever I put that. My favorite, I think it's over here, yeah. So on Asus, it's like in a different tab, Asus overclocking profile. And you can see here, I've already got a lot of different profiles because I've already overclocked it, but the profile name is, we can put 4.4 test. And we save that to 7. So yes, so now 4.4 test will come up and we can move on with life. We can save changes and exit and get back to Windows and start stress testing. Now we're back in Cinebench, IDA64 and Dota 2, but we're just gonna open up Cinebench, IDA64 first, and get that crack-a-lackin', and see if we got a stable overclock. So CPU ID, we bring that up. That's just to make sure that our 4.4 is indeed locked in, and it's saying it is. And then we go to system stability and we just hit start. And I'll put the links for all this stuff in the description below if you want to download it. But we just let that run now. Usually I let it run for 10 minutes to make sure that the CPU cooler is working fine, nothing's blowing up, but also our overclock is relatively stable. If it passes 10 minutes in either and the heat's pretty good and also hasn't crashed, then you know you're at least close to a stable overclock, if anything. So we just finished the stress test. After 10 minutes, it's actually closer to 13 minutes. The temperatures are absolutely fine. Maximum was only 62 degrees, and it's about 22 degrees ambient in here. So that is a benefit of X79, is that you have the CPU and that's soldered from the die to the IHS. That enables it to get lower temperatures. Of course, we're using the Corsair 280mm H110, which is a pretty good all-in-one cooler too. Besides that, we can take it a bit higher though. But we'll quickly run Cinebench. If you're happy with 4.4, you can run Dota 2 as well. And if it runs a game of Dota 2 for 20 minutes, it's going to be pretty much rock solid stable. But we'll quickly open up Cinebench, make sure our scores are absolutely fine as well. We should be getting, I'd say, close to 1500 at 4.4, but I'll double check. There we are at 4.4 gigahertz. We're getting 1556 CB, which is actually a lot better than I expected. So we're going to quickly restart the computer, go back into the BIOS, and then go for 4.6. And now we're back in the BIOS. There's only a few settings to change around here, but they are important, of course. First being the core ratio, upping this from 4.4 gigahertz to 4.6. So we just changed that to 46, lock that in. Now, it's important to note that on the Ivy Bridge 1680 V2, this is already kicking into diminishing returns. After 4.5, you start to get diminishing returns hard, and we'll show this later. So already above diminishing returns. And with that, we're going to have to up the CPU V core manually as well. I'm going to go with 1.36 as opposed to 4.4, which I initially needed 1.24, 1.25 volt. You can just start to see that the voltage already, the increase that we're giving here is quite sizable, because voltage also doesn't scale linearly, even though it may look like it is. This is actually using up a lot more power in relation to 1.36 in a number form versus 1.24. So do be very careful once we go past these levels. Of course, on Sandy Bridge, the 3930K, they generally overclock higher for the same voltages. So you may be able to get 4.7, 4.8 at around 1.36 to 1.4 volts. But after that, I wouldn't really take your CPU that much higher unless you've got some seriously good cooling and maybe some VRM cooling as well. Also, before we lock in 4.6 gigahertz, one important setting that I believe I left out is internal PLL overvoltage. We will want this enabled. This will essentially allow more voltage to travel to the CPU, which in this case at 4.6 gigahertz on the 8 core, it will need. So we're back here now after 10 minutes and everything is looking absolutely fine. But one thing I noticed straight away is the fans are noticeably louder in my Corsair Air540 case. And that's because, of course, there's more temperature. The temperatures are a little bit higher as well. They're reaching 70 degrees now, which is still absolutely fine on this platform. Still well within spec. You would want to ideally keep it under 80 degrees 24/7 just for peace of mind. And of course, longevity, which of course on X79 you will definitely want to keep, since this is a keeper, this one. But also we're going to quickly run a stress test now. So we're going to stop this stress test and just run a Cinebench run and just make sure the scores are lining up as well with our 4.6 gigahertz overclock. Now, because we got 1556 before, we do want to get a higher number. It can not considerably more, but we would want to get a higher number just to make sure that everything's running okay. But there we go there, blue screen. So what we're going to do now is actually go back in and yeah, we have to pump more voltage into this overclock. So we saw that we passed at the diminishing returns is crazy. This is the Ivy Bridge variant. So diminishing returns are crazy here. So we're going to go back in and make sure that voltage probably need about 1.38. I'm guessing, a little bit more. And then after that, we'll start overclocking the memory. So there's a Cinebench score run finished at 4.6 gigahertz, but the amount of extra voltage we needed to pump into this CPU to get it to this level is not worth it in my opinion. And just to prove it, I'll quickly restart the machine and run the exact same Cinebench run at 4.4 gigahertz at 1.25 volt. So now here we are with the final part of this tutorial, and that is overclocking your memory. It's pretty simple here because we've got quad channel. We don't have to worry a whole lot about the speeds themselves because the bandwidth is going to be huge with 4 DIMMs together. Now, if you can use XMP profiles, do lock them in because they do tune all the other intricate timings as well that you generally wouldn't have to waste time on. And of course, it helps fast track. But what we're actually more concerned with here is getting these timings, the CL timings, down as low as possible. So we go down to our DRAM timing control setting, and we go into here, and we can see that I've already actually pre-tuned my memory. It's not that good. The 4 sticks that I have in here are just ordinary Vengeance 1600 megahertz DIMMs. And so I'm able to get them down to 8, 9, 9, 26, and 1 command rate. So your luck and your mileage may vary. You may be able to get this to 7, 8, 8, 24, or 23, or 24, for example. But for me, I can only do that. So what you have to do is I'd recommend finding the lowest latencies at 1600 megahertz or 1866. Of course, you can go for higher speeds, but it's not really that beneficial, as opposed to lowering all these latencies to as low as possible on this platform. That's just my recommendation. We've established already that having your CPU at 4.6 gigahertz or 4.7 is not really worth it with the Ivy Bridge variants. With the Sandy Bridge variants though, going to 4.7, 4.8 is usually quite doable. So here for me, 4.4 is sort of like my everyday overclock because I don't need to pump a whole lot of voltage in it. And the results, really, I'm getting extra 80 CB for so much more power consumption, so much more heat and strain on my CPU. It's just not worth it. 4.5 could be worth it. I just don't really have time at the moment to play around with it a whole lot. But I believe it would still, the diminishing returns on this CPU, I believe, is at 4.4 for me. So I'm happy with that overclock, and I'm also happy with this DDR3 1600 megahertz. But of course, what about the voltages for this? So we're going down here. We've got important voltages here are system agent voltage as well. That can help with memory overclocks. But of course, the DRAM voltages themselves. We've got 1.55 here on both. That's just a little bump over the XMP profiles, which are 1.5. And because we've got so many memory sticks, increasing this will increase power consumption too. So do keep that in mind. So for me, I like to find the sweet spot of lowering the latencies, but still keeping the voltage quite low. So 1.55 is where I've found the sweet spot for my memory with the lowest latencies possible. And that's what I do recommend to people with overclocking memory. Now, the VTTs here, they're usually half of what the DRAM voltage is, so you can leave them on auto and they should automatically be half of what this is. Now, on certain motherboards, for instance, if this here can't lock in, because you can see here, it pretty much can lock in half of what this is here. But in certain motherboards, if it can't lock in half of what it is, then you may wish to set in, for instance, see there's half of what we've got, so we're fine. But for instance, you may wish to lock in 0.18 to 1.6. If you can do it manually, like for instance, instead of putting 1.59, it doesn't have the setting here to go to half, then you may wish to just bump it a little bit and make sure it's just half of that. So that is a little trick to helping with memory overclocks, especially on mediocre boards. But since this is a board with so many different settings, it's not a problem. You can leave that on auto. So that's about it really. You got Memory Tweaker's Paradise, which again I find is for LN2 overclocking and extreme overclocking. A lot of settings here that I actually don't fully understand. But with that aside, we can go to save and exit changes and just go back into Windows and then stress our memory. So now we're on the final test here, and we're going to use i7-3930K, but instead of having all these options checked, which I usually like leaving checked since it's really indicative of real world stress testing. For instance, if I edit videos in Premiere Pro, This here pretty much stresses the exact same heat and wattage out of the CPU. But what we're going to do for the memory test alone is just take those 3 options off and just leave stressed system memory, and then hit that and go for 10 minutes, and then we'll come back. So there's the memory test. That passed absolutely fine. If you do come into problems while you are doing these tests, then you may have to bump voltages just a little bit or lower speeds to what I've got here in this guide just a little bit. But keep in mind, when I first started the 4.4 gigahertz, for example, I'm pretty sure what I set in was pretty much obtainable by anyone out there with decent gear. Now also with the 1600 megahertz, you should be able to achieve these clocks with a decent quad channel kit of memory as well. So what I've locked in here is pretty safe. It's pretty good for 24/7 use, and it's not going to damage any of your gear. Now all there's left to do is play a bit of Dota 2 and make sure everything's running a-okay. And that's about it for the overclocking tutorial for X79. I hope you guys enjoyed this one. If you did, then be sure to hit that like button. Also, let us know in the comment section below if you need any help or there is anything you don't understand. I'll be sure to get back to you as soon as I can. Or of course, if you just want to leave a comment on how much you love X79, then be sure to do that too. But with that aside, we saw some of the diminishing returns there actually kick in live with the difference between that 4.4 gigahertz and 4.6. Now I will state that again, this is on the Ivy Bridge 8-core version for X79. The Sandy Bridge 6-core, for instance the 3930K, should be able to get up and boogie it around 4.7 gigahertz, 4.6. After that, it may hit its own diminishing returns, where you'll see some people get 4.8, for example, or even 4.9. This CPU I've got here most likely will top out at 4.7, and even then you'd need good cooling to keep it under control. 4.6, we got that today, but again, the amount of voltages that needed as opposed to 4.4 was just way too much. In my opinion, it's not worth it for that extra 200 megahertz. So there, that's diminishing returns. You guys got to see that live. And with all that aside, I'll catch you in the next tech video very soon. Peace out for now. Bye.